Assalamualaikum warahmatullahi wabarakatuh. Today, our group will present about absolute temperature. So, our group consists of me, Muhammad bin Shirfan bin Azhar, Chua Wei Siong, and Daniel Fakrullah. Introduction. What is absolute temperature? Absolute temperature is the lowest possible temperature where nothing could be colder and no heat energy remains in a substance. Absolute temperature is the point where the fundamental particles of nature have minimal vibrational motion, retaining only quantum mechanical zero-point energy in this particle motion. It is defined as precisely 0 Kelvin on the Kelvin scale, which is thermodynamic absolute temperature scale, negative 273.15 degrees Celsius on the Celsius scale, and negative 459.67 degrees Fahrenheit on the Fahrenheit scale. Problem statement. Firstly, to understand the absolute temperature in terms of physics interpretation. Secondly, we are wondering whether is the negative absolute temperature exists. Thirdly, if negative absolute temperature exists, are we able to approach it? The next one, what is the strange effect below zero on the absolute temperature? And the last one is, as temperature studies are also related to energy conversion, we want to find out what happened to particles at negative absolute temperature.
My name is Daniel Fakrullah bin Masbari. Today, I will present the discussion about the absolute zero temperature. The first point is, absolute temperature is the pressure measured using the Kelvin scale where zero is absolute zero. Any thermometric scale on which a reading of zero corresponds to the theoretical absolute zero of the pressure, that is the thermodynamic equilibrium condition of lowest energy, is known as an absolute temperature scale. The Kelvin scale is employed in the physical science whenever thermodynamic concerns are essential. The temperature of a gas is defined by the chaotic movement of its particles. According to the physical definition of temperature, that is, the colder the gas, the slower the particles. So, nothing can be colder than absolute zero on the Kelvin scale. And the second point is the majority of systems, including a classical gas such as the air we breathe, are confined to positive absolute temperature. A system must have an upper bound for the energy of its particle in order to reach negative temperature. This negative absolute temperature have several apparently absurd consequences, although the atoms in the gas attract each other and give rise to a negative pressure.
As a result, absolute zero is a point at which fundamental particles of nature have minimal vibrational motion, retaining only quantum mechanical zero-point energy-induced particle motion. So, absolute zero cannot be reached only using thermodynamic means, because the temperature of the substance is being cooled, and a system at absolute zero still possesses the quantum mechanical zero-point energy. So the energy of its ground state at absolute zero, the kinetic energy of the ground state cannot be removed. Scientists and technology made a great advancement in achieving the temperature close to zero. So thus, nothing can be colder than absolute zero on the Kelvin scale. As a conclusion, absolute zero is the coldest temperature imaginable, at which nothing could be colder and all heat energy in matter is lost. Absolute zero is the point at which basic particles of nature have the least amount of vibrational motion, and only quantum mechanical zero-point energy-induced particle motion remain. Absolute zero is also defined as 0 K on the Kelvin scale, which is a thermodynamic temperature scale, and negative 273.15 degrees Celsius on the Celsius scale. According to the international consensus, 0 degree are on the Rankine scale, and also negative 459.67 degree F for the Fahrenheit system are likewise exact equivalent of absolute zero. So, while scientists have yet to attain a condition of zero thermal energy in a substance, they have made a significant progress in achieving temperatures that are progressively near to absolute zero. Thank you.